Hi, second graders. So we are going to be doing lesson 17 today in math, and y'all should remember doing this lesson last week, maybe the week before. So this is a lesson that we've already done, but we decided as a second grade team, the teachers decided that this would be best if we kind of do some review lessons and lessons that we've already done, since this is a new way of having school. So yeah, if you are like, okay, I've seen this before, Miss Marshall, we've already done this. I am doing this on purpose. I want us to just kind of get us some review in, and also get us familiar with this type of learning with something that we've already done. So we are going to be today pairing objects and then counting them by twos. We're doing that so that we can connect that idea in counting by twos, that the numbers in the ones place with the digits 0, 2, 4, 6, and 8. So we're going to see kind of a pattern in some of these numbers that we're working with today. And we will know that we have it when we can correctly determine if a number is even. So let's start with some subtraction review. So we're going to solve some subtraction problems and then use what we know to solve similar problems. So first off, what is 11 minus 9? Go ahead and tell me, what is 11 minus 9? Okay, 11 minus 9 is 2. How can we use that fact to solve 21 minus 9? Go ahead and tell me. You can tell your computer screen or your tablet. How can we use that fact to solve 21 minus 9? Okay, so I'm gonna pull out my whiteboard here. Sorry, I'm trying to do things with my phone in one hand and my marker in the other hand. Okay, so if we know that 11 minus 9 equals 2, we're wondering, how can we use that fact to solve 21 minus 9? Well, I know that 21 is 10 more than 11. So if 21 is 10 more than 11 and 11 minus 9 is 2, then my answer for 21 minus 9 should be 10 more than my answer for 11 minus 9. So 21 minus 9 is what? 21 minus 9 is 12. Okay? Now, at this point, and I should have told you this before, I'm sorry, I'll list the materials that you'll need for this lesson at the beginning. But at this point, if you can just go ahead and get out like a scrap piece of paper, piece of notebook paper, notebook, whatever, and a pencil, we're going to keep a list of all of the subtraction sentences that we're creating here, okay? So we have 11 minus 9 equals 2, 21 minus 9 equals 12. How can we also use 21 minus 9 equals 12 and 11 minus 9 equals 2 to solve 31 minus 9? Go ahead and tell me that now. How can we use 11 minus 9 equals 2 and 21 minus 9 equals 12 to solve 31 minus 9? Okay, so if we're adding 10 each time, or if you notice that we're adding 10 each time, that means that our answer with our total, we're adding 10 to our total each time. That means that our answer is also going to go up by 10, right? So 11 minus 9 is 2, 21 minus 9 is 12, 31 minus 9 must equal 22. Now, of course, it would be nice to go back and use some of your strategies to double check this, but what we're focusing on is how this first additional subtraction sentence can help us solve similar subtraction sentences, okay? So now what about 41 minus 9? And if you can, be keeping a list of these subtraction sentences, just like I'm doing on my board. Okay, so 11 minus 9 is 2, 21 minus 9 is 12, 31 minus 9 is 22, 41 minus 9 must equal what? 32. Okay, so now what I want you to do is on your piece of paper, it can be any type of paper, whatever you can write on, I want you to continue making subtraction sentences, starting with 11 minus 9 and continuing the pattern. I want you to solve as many as you can, and I'll give you like a minute to do that. As many as you can in this pattern, or using this same pattern. Okay, so if we were going to continue this pattern, the next sentence, the next subtraction sentence in the pattern, or in the sequence, we could say, would be 51 minus 9 equals 42. 61 minus 9 equals 52. 71 minus 9 equals, 62. Sorry about that. And then 81 minus 9 equals 72. And then I have ran out of room, so I'm going to just twist my board over here. 91 minus 9 equals 82. And if we want to reach all the way to that 100, we could say 101. Well, I'm gonna make that a little bit smaller. Sorry, y'all, I'm having to improvise. 101 minus 9 equals 92. So if we look at our totals for each of the subtraction problems, we see that pattern going up by 10, but we also see that our answers are going up by 10 as well. Okay? All right, let's look at another example of that. So if you'll give me one quick second, I'm gonna erase this, and then I'll be back on the screen. So give me 1 second. Video's not over. Oh my goodness, and of course it's not wanting to erase. Okay. I'll try this one. Okay, clean board. So now we're not going to do all 3 of these just because I don't want this video to be super long and I want to get into the meat of the lesson. Let's look at, let's do this one, 11 minus 8. We're going to do 11 minus 8 to start off our pattern sequence. Okay, so if you have your scrap sheet of paper, you can go ahead and start this new sequence of subtraction sentences. So we're going to start with 11 minus 8. So tell me, what is 11 minus 8? It is 3. Okay, so now, how can 11 minus 8 help us solve 21 minus 8? Go ahead and tell me. Tell the screen. Or tell me. You're telling me. How can 11 minus 8 help us solve 21 minus 8. Okay, so if we're looking at our totals, we're adding 10 to the total of this subtraction sentence. We're still subtracting 8, so our answer will have 10 added to it. So, it'll have 10 added to the same answer that we got for 11 minus 8, and that's how we're using 11 minus 8 to help us solve 21 minus 8. Okay, so if 11 minus 8 is 3, then 21 minus 8 must be 13. Okay, I'm going to give us the next pattern, or the next, and I'm going to write this a little bit smaller so I don't run out of room this time. I'm going to give us the next addition sentence or subtraction sentence in the pattern, and then you're going to do the rest. So 11 minus 8 equals 3. 21 minus 8 equals 13. 31 minus 8 must equal, looking at the pattern, 23. Now, you complete the rest of the subtraction sentences on your paper. Do as many as you can in the time that I'm going to give you, and then we will go over them. Okay, so go ahead. And if I'm moving too fast at any point, you can just hit that pause button and kind of help yourself get caught up. This is one good thing about virtual learning is you can't hit pause in real life. So if I'm ever moving too fast in real life, speeding you up through those transitions, you can always just hit pause over your computer and kind of work at your own pace, which I completely understand. All right, so after 31 minus 8 will come 41 minus 8 equals 33. 51 minus 8 equals 43. 61 minus 8 equals 53. 71 minus 8 equals 63. 81 minus 8 equals 73. 91 minus 8 equals 83. And then 101 minus 8 equals 93. Sorry, I'm kind of showing this sideways a little bit. Okay. All right, so we're going to move on. I'm going to erase this. Hopefully it'll erase this time. I'm going to put the phone down for a second. The video is not over. I'm just putting it down so that I can erase the board. So 1 second. Okay, thank you for being patient. Hi. Okay. So now let's look at our application problem. Okay. So again, this is one that you've seen before, but we're still going to practice it. So it says 7 students sit on one side of a lunch table. 7 more students sit across from them on the other side of the table. Letter A, draw an array to show the students. Letter B, write an addition equation that matches the array. 3 more students sit down on each side of the table. So right here where it says 3 more students, we're going to do that separately because this is going to require 2 steps, and I want us to do 1 step at a time. So right here where it says 3, as you're solving this on your own or solving it with me, you can kind of just like pause right here, and we'll come to that when we finish the first half of the problem. Okay, so now on your piece of paper, at this point you might need to grab another piece of paper. Again, it can just be like a scrap piece of paper, notebook paper, paper that's in a notebook, whatever you can find that you can write on. I want you to go ahead and draw an array to show the students as they're sitting across from one another on each side of the table. And remember, there's 7 students sitting on one side of a lunch table, and then 7 more come and sit down. So remember, with word problems, they're like a story. So we kind of just have to follow along as we would if we're reading a story. Okay, so I'm gonna give you a little bit of time to solve that, to draw your array. Within this time, if you finish drawing the array, you can go ahead and write your addition equation that matches your array. And again, if I'm moving too fast, feel free to just go ahead and hit the pause button so that you can have time to finish what you need to finish on your application problem. Okay, so looking at letter A, we were to draw an array to show the students, okay? So I'm gonna just put a little A right here to show that this is where I'm solving letter A. I'm gonna solve it kind of like in this space here. So when I think of a lunch table, I think of a long rectangle, and I think of people or students sitting on one side and some more people sitting on another side. And when I visualize that, I kind of visualize an array. So this is perfect that they're having us draw an array to represent those students, because when I think of arrays, I think of objects or counters or whatever you want to call them, or whatever you're working with, across from each other, just like students sitting at a table, at a lunch table, okay? So I'm going to start with the first 7. And I'm not going to draw little stick people, and you don't really need to either. If you did, that's fine. But again, when we're drawing these arrays, we can just use X's or circles just to make things quicker and more efficient, okay? So I'm going to draw the circles to represent the 7 students sitting on one side of the table, okay? Okay, so to double check, 1, 2, 3, 4, 5, 6, 7. So 7 students sitting on one side of the lunch table. Okay, 7 more students sit across from them on the other side of the table. So now I'm going to draw the other side, the students that are sitting across from them. Okay, 1, 2, 3, 4, 5, 6, 7. All right, so here's our array. Now, I'm going to ask you, how many rows are in this array? How many counters are in each row? Okay, so we have 2 rows of 7. 2 rows of 7. Now I'm going to ask you how many columns. And remember, rows go this way, like this. And columns go this way, like this. All right? So how many columns are in this array? How many counters in each column? Okay, so we have 7 columns with 2 in each column. Okay? So this is what your array should look like. If you had drawn a line down the middle, that's perfectly fine too. Sometimes it helps us to see each row or each column, whatever it is that we're using to divide the array. Sometimes it helps us to see visually each column and each row. So if you drew a line down the middle, that's perfectly fine. All right, so for letter B in the word problem, it says, write an addition equation that matches the array. Okay, write an addition equation that matches the array. So we're mostly focusing on the rows here. And just a second ago, we discussed how there were 2 rows of 7, right? So 2 rows of 7. So I'm adding 7 twice. So 7 plus 7 would be my addition sentence to match the array. Okay, now tell me, what is 7 plus 7? 7 plus 7 is 14. And we've been, over the past couple weeks, we've been working a little bit with multiplication. So this would be an example of multiplication. We're adding 7 2 times. So that would be 7 times 2, because we're adding 7 2 times. And 7 times 2 would be 14. Excuse me. All right, so let's go ahead and go into the second part of the problem. And I'm gonna draw a line down the middle just so I can see each part of the problem differently. So they tell us in letter B that 3 more students sit down on each side of the table. So I'm going to, and I would say that even though that's written under letter B, I'm gonna put that with letter C. So I'm gonna put a little C right here. And I'm gonna go ahead and draw the original array with 7 students on each side before I add 3 more students. Just so I can kind of keep a good record of what's going on here, okay? So, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? So it says that 3 more students sit down on each side of the table, each side. So I'm going to add 3 to each of my rows because 3 come and sit down on each side, 3 more. Okay? So 1, 2, 3. 1, 2.